Okay, so 10.3, we just learned about probability and basic probability, like drawing a face card, drawing a 10, playing cards, or just one event happening. So in 10.4, we're going to learn about multiple events happening. So what could happen if I drew a face card and a 10? What is the probability of that? Or what is the probability of drawing 4 2s in a row? So we have what we call a union, and that's just when two events happen at the same time. So if you look at the Venn diagrams, the first 3 Venn diagrams, the first is called a union, which would be when A and B, when they occur at the same time. So you could either have event A or B happening, and that would be when you add them together, or you could have when A and B happen together, and that's what's called the intersection. So intersection is just A and B. Union would be A or B. So when you're including A or B, you're including all of A and you're including all of B. So what is the probability of rolling a 1 or a 2? You would take the probability of rolling a 1, which is 1/6, plus the probability of rolling a 2, which is 1/6. So you add them together and it becomes 2/6 or 1/3. If you're talking about the intersection, it's when they both occur at the same time. So if you look at the third Venn diagram right here, you'll notice that they do not ever occur at the same time, so they don't ever intersect. And so we would call those events mutually exclusive. So the last example that I just gave, where I said what is the probability of rolling a 1 and a 2? If I only roll the dice one time, is that possible? No, I can't roll a 1 and a 2 at the same time if I'm only rolling it one time. I could roll a 1 and then roll a 2, but if I'm just rolling the dice one time, I can't get both outcomes. So that just means that they have no intersection. Mutually exclusive means that they have no outcomes in common. They never, ever, ever happen at the same time. So they have no overlapping events. So this formula right here, you will be given this formula. It's not something that you have to memorize, but we'll be using it a lot. And so what that's saying is, if you have an event A or B that happen, so what is the probability of so in a deck of cards, drawing a 2 or drawing a club, then I would take the probability of drawing a 2, which would be my A. I would take the probability of drawing a club, which would be probability B, and then I subtract the 2 of clubs because I'm counting it twice. So that kind of makes sense. So you're subtracting away the intersection. But you'll have this formula. So, okay, so let's look at number 2. It says a card is randomly selected from a standard deck. What is the probability that it is a face, card, or a diamond? So, probability of a face card, we have already said that is 12 out of 52. Exactly. So we're going to get to that here in a second. What is the probability that it is a diamond? 13 out of 52. 13 out of 52. And what is the probability that it is a face card and a diamond? So how many of those actually overlap?
Only 3.
So face and diamond. If you think about it, how many of those are face cards that are diamonds? Well, face cards are king, queen, and jack. And there's going to be 1 of each suit. So there's 12 face cards total. 3 of those would be diamonds. So that would be 3 out of 52. What's the formula for it? It's at the top. So the probability of A or B is the probability of A plus B minus A and B. So what I did, if you want to write it as A and B, this is like A, this is B, this is A and B. So if I were to plug it into the formula, I'm going to add face, I'm going to add diamond together, and then I'm going to subtract away the face and diamonds, because the reason why we subtracted away is because we kind of counted it twice. Like we've counted all of the face cards, and then we've counted all of the diamonds. Well, I have counted the king, queen, and jack of diamonds twice. So I want to subtract one of those sets away. So you get 12 out of 52 plus 13 out of 52 minus 3 out of 52. And that should give you 15 minus 3, or 25 minus 3 would be 22 out of 52. And that reduces to what? 11 over 26. Does it go anymore? I don't think so. Because they intersect. So they happen at the same time. So if I look at number 1, 10 and face card, they don't intersect. Like there's not a 10 that's a face card. There's not a face card that's a 10. But face card and diamond, they do intersect. So if you think about, like sometimes I like to draw a Venn diagram. So if I think of my face cards and I think of my diamonds, I have a king, a queen, and a jack that are both face and diamonds. So they have an intersection. But then if I think of tens and faces, they don't ever intersect. They don't have anything to overlap. So you have to subtract the intersection away from that. Okay, let's look at number 3. So it says out of 200 students in a senior class, 113 are either varsity athletes or on the honor roll. So what I like to do is I like to highlight the important information. So 113 are varsity or honor roll. So I'm going to go ahead and write down here the probability of A or B is 113 out of 200 because it tells me that there's 200. And we'll call varsity athletes A and we'll call honor roll B. So there are 74 students who are varsity athletes and there are 51 seniors who are on the honor roll. So if we're calling athletes A, the probability of A would be 74 out of 200. And the probability of B, which we are going to call honor roll, is 51 out of 200. So what is the probability that a randomly selected senior is both a varsity athlete and on the honor roll? So I want to find like where they intersect, like they're an athlete and they're on the honor roll.
Would that be out of 200 or out of 200?
Out of 200, because there's 200 students total.
Oh, yeah.
So I'm going to take my formula, which was given to me, which is the probability of A or B equals A plus B minus A and B. And I'm just going to plug in what I know, and I'm going to solve for the missing piece. So I know A or B is 113 out of 200. A is 74 out of 200. B is 51 out of 200. And I don't know A and B. You could call it X, or you could just leave it as A and B. Doesn't matter. So then I want to solve for the probability of A and B. So I could move the probability of A and B over and then subtract the 113 minus 200. And since they're all over 200, you could technically drop the 200, but we want to find the probability at the end, so I'm going to leave it. So the probability of A and B is 74 over 200 plus 51 over 200 minus 113 over 200. So when you put that in your calculator, I think you end up getting 125 minus 113. Is that right?
Yeah.
And so then you would have 12 over 200.
There's quite a small change.
And you end up getting, that reduces to 3 over 50. Oh, that is sad.
Every single person
Okay, so the next thing that we'll talk about is a complement. So essentially, whenever you have the probability of A, like let's say that that's 30%, the complement of that would be 1 minus whatever A is. So it's like the opposite. So if I have a 30% chance of making an A on the test, then I have a 70% chance of not making an A on the test. So it's a complement is like saying not event A, not whatever what you're finding the probability of. And so to find the complement, you just do 1 minus whatever your probability is. So I could either roll a 6 or I could not roll a 6. I could make an A on the test, I could not make an A. So it's just whatever your event is, it's the exact opposite of that. So if we look at number 4, I have 2 6-sided dice that are rolled, and there are 36 possible outcomes that are shown. So what is the probability that the sum is not 6? So we have a diagram over here on the right that kind of has listed out all the options for us, so we don't have to do that, of possible outcomes. So the easiest way to do this, instead of counting the ones that are not 6, are to count the ones that are 6 and then subtract. So I want to do 1 minus the probability of rolling a 6. So if you look at your graph or your little chart diagram, I'm going to circle all of the ones that are not 6. Or that are 6, I'm sorry. So we have 1, we have 2, 3, 4, 5. Yeah, I'm looking for the sum. So I have 1 and 5, 2 and 4, 3 and 3, 4 and 2, 5 and 1. So the probability of it adding to 6 would be 5 out of 36. And why is it only 5 and not 6?
Because if you can't have a number plus 6 equals 6.
That's right. Also, the 3 and the 3, they only count one time because the order wouldn't matter on that, the 3 and the 3. So I would do 1 minus 5 out of 36, which gets me 31 out of 36. What is the probability that the sum is less than or equal to 9? So what are the ones that we could circle that would be easier? More than 9. So I could find all of the ones that are more than 9. So we have 5 and 6, or 4 and 6, that's 10. 5 and 5 is 10. 6 and 4 is 10. 5 and 6, 6 and 5, 6 and 6. So all of these past this diagonal right here are greater than or equal to 10. Or they're greater than 9. So the probability of getting greater than or equal to 10 is what? 1, 2, 3, 4, 5, 6. So 6 out of 36. So 1 minus 6 out of 36 would be 30. 30 out of 36, which reduces to 5 over 6. Okay, and then the last part, this type of graph shows up, or this type of table shows up on the SAT a lot. And so the last thing that we'll talk about is conditional probability. Conditional probability is when you have a condition that you put on it. So what is the probability that you, I guess in this graph right here, that you read a nonfiction book if you're under 21? So now we're only going to look at the under 21 group instead of the whole population. So conditional is like you're just putting a condition out of it and you're only isolating that group or that specific section of people or whatever you're surveying. So it has to have the word if or given, and that's going to tell you that it's a conditional. So it'll say given or it'll say if. clue, if, or given, right here. So if the question says if or given, then that means that it's going to be a conditional statement. So we're going to be able to read what we have right here is a two-way contingency table, and we're going to be able to find probabilities based off of reading this table. So here the table is type of book downloaded to a computer tablet, and they've divided it amongst age groups and then also the type of book or the classification. So nonfiction, action, romance, science fiction, and then they have the totals in the columns, and then this 140 is going to be the grand total. So we always take everything out of the grand total unless it's a conditional statement. So number 5, it says what proportion of individuals surveyed downloaded a romance novel? So what section do I want to look at? How many people downloaded a romance novel? 45. So 45 people downloaded a romance novel, and there are 140 people total. And then I can put that in my calculator, and it reduces to 9/28. And let's just leave it in a fraction for right now. The next question says, what proportion of individuals surveyed are 22 to 50? So now what number am I going to look at? How many people are 22 to 50? 59. So 59 people are 22 to 50, and that is out of 140. Does that reduce to anything? No, so I'm just going to leave it. Number 7, what proportion of individuals surveyed are over 50 and downloaded a nonfiction book? So I'm going to look at the intersection. This is where the column and the row intersects. I'm going to look at over 50, so that's this right here. And I'm going to look at downloaded a nonfiction book, which is this column. What is the number of where they intersect? So they are both over 50 and nonfiction. 14. So this proportion would be 14 out of 140. And that reduces to be 1/10. Okay, number 8 is a little bit different because we have an or here. So what proportion of individuals surveyed were either under 21 or downloaded an action novel? So this is where that formula kind of comes into play. So there's 2 ways that you can do this. You can take the total of under 21. So what's the total of under 21? 38. Plus the total of downloaded an action novel, which is what? And then I'm going to subtract their intersection, which is what? 14. Why would I subtract that intersection? Yeah, because I counted it already, so I counted it twice. And then I put it over the total, which is 140. So 38 plus 37 minus the intersection over 140. That gets me 61 over 140. Another thing that you can do if you don't want to subtract the intersection is I highlight all of the cells 2, 14, 15, 7, 10, 13. And you can just add all of those together. So 2 plus 14 plus 15 plus 7 plus 10 plus 13. And you're doing the same thing, but you're only counting the 14 once. So it makes like a little T. It makes a cross. So that you can do that as well. Or you can add the totals, subtract the intersection. It's up to you. Either one will work. And then the last one, what proportion of individuals download a science fiction novel given, so here's my condition, given they are under 21. So what we do here, instead of looking at the grand total of 140 people, because not all 140 people are under 21, I'm only going to look at the under 21 row, because that is my condition. So out of all of the people that are under 21, which is 38, how many of those downloaded a science fiction novel? 7. So I'm going to say 7 out of 38. So I changed my total because of the condition. My condition was that it was under 21. So I only look at the 38 people that are under 21. 7 of those people downloaded a science fiction novel. And that doesn't reduce, so I leave it like that.